You touch a hot stove. Your hand is already moving before the word ow even reaches your brain. That's not a decision. It's a reflex called nociception, and it is almost unbelievably old. Sea slugs have it. Fruit flies have it. Animals with no brain at all have it, which raises a much harder question than it first sounds like. Almost everything on Earth can detect harm and pull away from it. The real question is whether detecting harm is the same thing as it hurting. Let's start with the gap. Because there is a real gap inside your own body, between the pulling away and the ow, your hand leaves the stove roughly 1/10 of a second before the pain signal even reaches your conscious brain. The withdrawal is a spinal reflex. The suffering, if there is any, arrives late as an afterthought, tacked on by a brain that had nothing to do with the decision to move. Which means even in you, reflex and suffering are two separate systems, running on two different clocks. Biologists call the first one nociception. A nervous system detects something damaging and generates an automatic response. No feeling required. A single neuron can do it. What biologists mean by pain is something else. An unpleasant, motivating experience that changes an animal's future behavior, not just its next half second. The trouble is, you cannot see an unpleasant experience under a microscope. You can only look for its footprints. So here's how you actually test it. First, does the animal only react in the instant, or does it change its behavior afterward in ways that cost it something? A crab that gets shocked in its favorite shelter and later chooses a worse shelter to avoid another shock is doing more than reflexing. It's trading a real resource for relief. Second, will a painkiller change the animal's behavior the same way it changes yours? If an anesthetic makes the difference between an animal favoring a place and avoiding it, that's a much harder thing to explain with a nervous system that isn't feeling anything. Third, does the animal tend an injury? Groom it, guard it, protect a hurt limb from a limb it would otherwise use freely. Reflexes don't nurse wounds. Only something like a self, managing something like a self, does that. Consider the animal that most changed this argument, the octopus. At San Francisco State University, Robin Crook ran what's called a conditioned place preference test, the same design used for decades to show that rodents feel pain. She let an octopus explore a 2-chamber tank and settle into a preferred side. Then she injected a small dose of acetic acid into one of its arms, like lemon juice on a paper cut, and let it retreat to whichever chamber it chose. Days later, the injected octopuses avoided the chamber where the sting happened. And when Crook gave them a local anesthetic before confining them to their least favorite chamber, the animals that had been hurt came to prefer it. The relief made the bad room worth staying in. Octopuses that only got saline showed no such preference either way. The anesthetic wasn't rewarding on its own. It only mattered if there was pain to relieve. The octopuses also nursed the injury. For at least a day afterward, they groomed the injected arm and tucked it away, sheltering it from the rest of their own body. That's not a reflex, holding still. That's an animal managing an injury it appears to know it has. And once you have that method, trade-offs, painkillers, wound care, you can point it at almost anything. Crabs. In a series of studies at Queen's University Belfast, shore crabs were given a choice between 2 dark shelters, one of which delivered a mild shock. It took only 2 tries before the crabs began avoiding the shocking shelter, giving up their preferred hiding spot to dodge it. A newer study out of Gothenburg mapped the actual nerve pathway. Acid applied to soft tissue triggered a signal that ran all the way from the shell to the crab's central nervous system and got stronger as the acid got stronger. Not just a twitch at the surface. A graded signal headed inward. Fish spent decades as the animal researchers were most confident didn't feel anything. No neocortex. The reasoning went no pain. That confidence has eroded. Most researchers who study this now think teleost fish, trout, goldfish, most fish you'd recognize, have nociceptors wired much like ours, and behavior to match. Fish with injured lips stop feeding normally until they're given a painkiller, then resume. Then there are the honest gaps. Insects are the biggest one. A bumblebee that's been shaken to simulate a predator attack becomes measurably more pessimistic on an unrelated task, which at minimum suggests something mood-like is happening in a brain the size of a sesame seed. But whether that tips over into anything resembling pain is genuinely unsettled, and most researchers say so. And naked mole rats are a stranger case still. They've evolved almost total insensitivity to the pain of acid and chili pepper compounds specifically, likely because their burrows fill with carbon dioxide, and dulling that one kind of pain let them keep breathing where other mammals couldn't. Proof that even within pain, evolution edits selectively, animal by animal, sensation by sensation. Which brings up the question that made this debate matter outside the lab. Why would evolution bother building "it hurts" when "pull away and don't do that again" already works as a reflex? The likely answer: a reflex only knows about right now. An animal that can learn, generalize, and change its behavior around an injury it's still carrying can avoid entire categories of future harm a pure reflex would walk straight back into. Suffering, uncomfortable as the word is, may simply be a better teacher than a twitch. This isn't an abstract argument anymore. In 2022, the UK folded octopuses, squid, crabs, and lobsters into its Animal Welfare Sentience Act, based on exactly this kind of evidence: nociceptors, painkiller responses, learned trade-offs. Which means the debate about whether a lobster feels the boiling water it's dropped into is no longer just a dinner party argument. It's now, in at least one country, a legal one, and we should be honest about what none of this proves. We can measure that an octopus avoids the site of an old injury. We cannot get inside it and check whether that avoidance comes with anything it's like to be that octopus. Every experiment here measures behavior because behavior is what we can see. Whether there's a light on behind it stays, for now, the one thing science can't reach. So, do animals feel pain the way you do? That depends on what you're asking. If you mean the exact first person, unmistakably you-ness of your own worst headache, we don't know. And for most species, we may never know for certain. But if you mean a system that detects damage, that an animal will pay a real cost to avoid, that responds to painkillers the way yours does, that nurses its own wounds after the danger's gone, then yes. In octopuses, in crabs, in the fish nobody used to take seriously, probably in ways we haven't tested yet, in far more animals than we've gotten around to asking. Which means the wince you feel when your dog yelps and looks at its own paw was probably never just projection. It was you, correctly reading a system built the same way yours was.